Hello, my name is Ekechi Nzewi. I'm a computer science major at Georgia Institute of Technology, and I am here to talk about my RIS 2022 project, which is on object detection and mapping for a robotic harvester. The goal of this project was to build a system which detects apples in a frame and passes that information to a robotic harvester, which will then proceed to harvest the apples. This system does this by taking in stereo images from a stereo camera, calculating the displacement based off the camera info, calculating the bounding box coordinates with a artificial intelligence model, and then passing all of that to a tracker which can track the apples across frames. This information is then mapped to a format that will be useful for the robotic harvester. Our pipeline also contains a canopy agitation system. All this means is when a frame contains detections of apples, if the model is unsure of whether an object is an apple or not, the canopy agitation system would use a leaf blower to send some compressed air at the apples, which it's unsure of. Hopefully, this will shake up the canopy and then prevent leaves from covering the apples, which will in turn increase our detection ratings. For our models, we chose one of two models. We trained both models actually. One is a YOLO V5 and the other is the Mask RCNN. The YOLO V5 was primarily for object detection, which is essentially just detecting an object in an image and drawing bounding boxes around the object and returning the coordinates of the bounding boxes. The mask RCNN, on the other hand, was for image segmentation, which not only returns bounding box coordinates, but it also returns masks, which contain the pixels for the object being detected. For our YOLO V5 model, we tested three sizes for our situation: the YOLO V5 Nano, YOLO V5 Small, and YOLO V5 Medium. Across the board, all three YOLO V5 models performed great. The mean average precision across the board was over 0.9, but we ended up going with the small because it had a smaller size, which meant we could put it on less complex hardware, and it also was the highest performing model. When it came time to compare the results of the two models, we noticed the YOLO V5 across the board predicted 90% of the apples. It missed a few and had some false positives, but across the board, it was better than the mask RCNN, which failed to predict a lot of the apples in similar situations, as you can see in these images. For future work, we plan on improving the capabilities of our models because these models were trained in the most bare minimum situation, so they aren't as complex as they should be. For example, the mask RCNN, only the head of the convolutional neural network was trained because we expected it to perform good with only the head being trained because the data set was so small. But from our results, it is obvious we need to do some more verbose training for the mask RCNN. Also, we have yet to implement the tracking feature of the pipeline. So now all we can do is detect apples in an image. But after implementing the tracking feature, we'll be able to track specific apples across frames. I would like to thank my mentor, George, and Abby, for helping me throughout this summer working on this project. I would also like to thank Rachel and John for giving me the opportunity to come here and interact with all these brilliant people, and Carnegie Mellon for sponsoring everything. Thank you.